one of the cool things about these, you can actually text these to people, believe it or not, and it works. I'm actually just going to use Slack to send it to my phone. Here we go. Here's the object. There is human female on my phone. You can actually embed it in the scene in AR. Now this is going to be extra hard to demo, but in theory, we can.
Hi, and welcome to the TD Meetup. My name is Alexander Richter. I'm a technical director for visual effects, animation, and games, and I worked at companies like WeatherFX and Framestore on Avatar: The Way of Water and Monsters at Work. And today I wanted to introduce you to our monthly event, the TD Meetup, where we meet each month to talk about all the current topics in visual effects, animation, and games. And it's perfect for people who are interested in the technical field and who want or are currently technical director. Today, we want to talk about USDSkel. And this is also a follow-up topic that we had before, USD for visual effects with Bertrand Cabrol. A detailed approach into USDSkel is basically we want to explore what it is. Some people maybe don't really know what it is because this is something very specific. I think one of the elements that took the visual effects, animation, and games by storm is USD, but it's also kind of more on a simmering mode. Like, it's coming, people slowly moving into it, studios transitioning into USD, and everyone talks about it. Actually, if you approach and ask like an interviewer, like what should you learn? And besides Python, USD is one of the topics people actually say as good to know, kind of be ready, production ready, knowing USD. And so I thought this would be a good addition. When I asked Paul, what can you talk about? He said, you know what, there's this cool thing, USDSkel, let's talk about it. I was like, okay, sure. Let me quickly introduce Paul Kanyuk. He is a lead crowd technical director at Pixar Animation Studio for over 20 years. He worked on Cars, WALL-E, Up, Brave, Finding Dory, and all these other projects, basically. Like 20 years at Pixar, I think you collect a bunch of things. One of my favorite movies that you worked on is Ratatouille. Especially love the rat scenes where they swarm around the car, in this alleyway when they find the health inspector, basically want to stop them. That's really cool. Love that. Paul wants to talk about what USDSkel is exactly, his background with it, and how we can potentially use it in the future and bring USD closer to where we are. We did an episode, if you're interested to know more about Paul later and how to work for Pixar as a technical director, we did a 21 Artist show. You can find it on my website, on the blog 21 Artist show. And we did one additionally to machine learning. So you can see like Paul is very interested in all these like research and technology things and stuff like that. And I think that's really cool. So if you're interested into also machine learning, not just AI or something, we also did an episode on that. So it's really, really interesting to look into that. Okay, let me give over to you and let us know about USDSkel.
All right, sounds good. I'm going to attempt to share my screen. All right, thank you for the great intro, and it's a pleasure to be working with you again, talk about pipeline topics. This one is on USDSkel and how OpenUSD can be used for character interoperability. So before we get into a lot of pipeline jargon, Alex already covered my background a bit. To elaborate a little more, I started in 2004 as a set shading intern on the original Cars film, went back to school, graduated, and when I got back full time, I was still working on Cars. But starting in 2006, that was the first time Pixar was using third-party crowd software, in our case, Massive. So they put all the new TDs to learn how to use it. So I was one of the people that learned how to use Massive at the studio. And since then, I've kind of developed a role at the studio for being a crowds guy, essentially. In 2012, it was my first time in leadership on the film Brave. Since then, I'm now the crowd supervisor on Toy Story 5. This is my 7th time being crowd supervisor. Can believe that. But that's not all I do. I do a lot of general software and research at the studio, typically in between shows. I like to say there's production season and research season, and I kind of go back and forth between the two. And along the way, I've done a lot of work with USD and pipeline, and that's sort of the topic I'll be talking about in this presentation more than crowds. But crowds is actually going to be the motivator for how USDSkel came about and how I became involved with it. So yeah, that's the motivation here. So now we're going to do a little bit of pipeline history at Pixar and talk about how USD came into the mix in USDSkel. So between 2006 and 2010, I worked with Pixar's crowd pipeline, which is a way of connecting Massive, which is a agent-based crowd simulator, to Marionette, which was Pixar's proprietary animation software. Note that's just the external name. We never called it that internally. Marionette basically handled a lot of disciplines from rigging all the way to lighting, and the crowd pipeline would take the rigs from rigging, we would simulate it, and then get animation curves back to apply on the characters in Marionette. And that's how we were able to use Massive. Now, there was a Marionette, very cool software, but it was getting pretty old by that era. And we actually had a complete overhaul and developed a new system called Presto, which is what we've been using for animation ever since. But Presto initially only handled rigging through simulation and didn't do lighting. So in order to make the film Brave and many films after that, we actually created a geometry caching system that would take the animation, the animated meshes and scenes from Presto, cache them, and then we would light them in our older software, Marionette, and then later tools like Katana and so on. But what that did is it kind of orphaned the crowd pipeline because it only understood Marionette rigs. So at that point, all that work kind of went out the window. And by the time I was working on Brave as crowds lead, there wasn't really the time or the ability to recreate that pipeline. So we had to take a lot of advantage of the fact that we're geocaching. And actually Pixar's crowd pipeline for many years was just a geometry cache sequencer. It would just take clips of animation, cache them out, and sequence them together to create large crowds. While that was very scalable and in some ways very simple, not having the representation of the character's skeleton limited what crowd tools we could use. We couldn't do things like blend clips of animation together. We couldn't do procedural lookouts or terrain adaptation. So we always knew we wanted to create a new skeletal-based crowd pipeline. But initially, we had to really work with geocaches. And USDSkel is kind of the marrying of the geocache and the skeleton into something that we would open source. But before we get that to USDSkel, let's take a step back to what are we talking about geocaching? We developed a format called TIDScene, or Time Index Dictionary Scene. That was a cache format. It was based on the Berkeley DB data structure, and it was very fast, kind of like Alembic, I would say. It's sort of what TIDScene was, but it was very layered. It supported having one TIDScene file reference another and so on. And we would actually have to develop a lot of plugins to bring TIDScene into Maya, to bring it into Houdini, and so on. And it was a lot of work for us. And every time there was a new version of Maya or Houdini, it would break. We'd have to work with the DCCs to get things fixed up. And it's kind of miserable pipeline maintenance. So one of the things we started was USD, or Universal Scene Description. It essentially was a way of taking our internal geocache format, TIDScene, making it a whole lot more robust, and then open sourcing it so that developers like Autodesk and Houdini could then use the code directly and maintain the plugins, and we don't have to. It also allowed Pixar to ensure that our high standards for what we expect from a 3D scene were supported by other softwares. A big example of that is OpenSubdiv. Every software had a different way to do subdivs that was kind of limited and didn't cover all cases. So we actually open sourced our subdivision technology to make sure everyone supported the highest quality subdivs, and we weren't making compromises elsewhere. So even though this was a lot of work for Pixar to develop and open source, and we're not getting paid for USD, we're sort of getting paid in that now the DCCs will support it, and that the things that we find important for filmmaking are now supported by the entire industry. So it's kind of a win-win for us in the industry to have done this. And at this point, there's now so many contributors other than Pixar to USD. It really belongs to the whole industry now. That said, it's still hosted on graphics.pixar.com.usd, which forwards to openusd.org. So before I leave this slide, just to talk a little bit about what it actually looks like, a USD file, which you see on screen left, is just a text file that defines like a bunch of scopes like world, Adam, Chars, Mike, and Mike, in this case, is Mike Wazowski, might have a reference to another USD file and brings that in and maybe overrides one attribute called layTX. So USD files can be large or small. They can reference or layer or inherit other USD files. There's whole different ways to put them together. So they're very pipeline friendly in that regard. It's kind of the basis of what we built Presto with. So it's been used in production for many years before it was even open sourced, essentially. So that's a little bit about how USD came about. I know there's probably lots more questions and stuff to discuss, but I want to move the topic over to USDSkel. So heading back to the crowd pipeline, we were faced with the challenge where, all right, we want to get our characters from Presto into simulators like Massive, Houdini, or Golem, and then bring the data back in. We need to talk about skeletons, which is not just meshes with points. How do we describe that in a way that all programs understand? Essentially, how do we create the best opportunity for character interoperability to move data in and out of Presto for characters? And one of the reasons this was a little tricky is Presto is one of the weirdest bits of software for characters because we actually don't use traditional skeletons internally. Our rigs are kind of a black box. You can think of them as black box that takes in animation controls and poses points. Underneath the hood, it's actually a node graph of deformers and weight objects with things called execution markers that allow there to be cycles in the ground. Anyway, it's very complex and it's very different from other rigs. Part of creating USDSkel was like a way to figure out how to create a sane version of our rigs for interoperability. And the reasons we want to do this, again, is to use crowd simulators. Also, if we want to do virtual production or previs, we want to be able to get our characters into those environments, or if we want to get them to games and so on, like working with Disney. So that was a lot of reasons we'd want to do this. Similarly, we want to get outside animation into our software. So again, crowd simulators, also mocap, or maybe even fancy motion controllers and machine learning. There's a whole bunch of reasons why it's in our interest to want character interoperability. So with that in mind, we worked on USDSkel. Now, what USDSkel is, this is the description from the OpenUSD org page. But as Alex and I were talking before this meeting, our docs are not the greatest for understanding concisely what the purpose of something is. So I'm going to paraphrase. It's basically the lowest common denominator form of a rig that any software should be able to understand. We're talking linear blend skinning or dual quaternion skinning. So just skinned meshes and blend shapes. That's it. Fancy pose-space deformation, no neural net deformers, none of that. It's like actually the very simplest type of rigging that's been around for decades, which in a way is kind of anticlimactic. If any of you are expecting me to introduce fancy new technology, there's nothing fancy about USDSkel. What's great is its simplicity and its ability to interchange. That said, one of the things we found with USDSkel is even the simplest possible rig has created controversy and headaches for all the DCCs to agree on. So even something simple is hard when you're talking about interoperating with multiple bits of software. So we do eventually want to build more rigging features into USD, but USDSkel is still a battle to get every DCC to fully support, even something as simple as just skinning and blend shapes. And I'll explain why in a little bit. So we're gonna dig in. But before we move on, basically USDSkel is blend shape and skinning in USD, as well as all the Python API for how to interact with those rigs. So it's not just a format, it's also the API for being able to read and write animated characters. So here's what it actually looks like if you dig into a USDSkel file. This is an example from the docs. That's just a arm. You can see that on the top of the file, there's something called a skel root, which is a collection of all the meshes and skeletons and skeletal animation that form a skinned character or object. In this case, it's an arm. And you define an array of joints. That's just a bunch of strings like shoulder, then shoulder/elbows, shoulder, elbow, hand. So it's both the name and the hierarchy. It's just encoded in those joint names. Then you have your bind transforms and rest transforms, which are essentially your rest pose. And then you have a scale animation scope, which is basically how the skeleton moves over time, in which case only the elbow has animation. So it doesn't have to be the full skeleton. It could just be a subset of the joints with animation. And you can have translations, rotations, and scales. Then you have a relationship that essentially binds the skeleton to the animation source. Then for the mesh, this is the actual ARM mesh. You can see a little bit about how meshes are defined in USD. You can see the vertex counts, 4, 4, 4, 4, 4. It's a bunch of quads, vertex indices, how they're all connected to each other, and then points, where they're located in space. Then you have a relationship that's binding that mesh to the skeleton. And then you have joint indices and joint weights, which you see, those are primvars that have an element size of 1. So in this case, every point is bound to one joint. But if it was an element size of 2, it would be 2, 3, so on. You can have as many influences as you want. This is essentially the num influences is your element size. And in this case, you see, some are 2, 0, and 1, and all the weights are 1. And then you have the geom-bind transform, which is where the mesh is located in space at bind time. So even though, yes, this is just a skinned mesh, you can see that there's a lot of pipeline intricacies in terms of rest pose and transforms. And we found that even something as simple as a skin mesh, different software had different restrictions on what was supported. We had to work with the DCCs to get all the permutations here working. And we'll explain a little more about that later. Before we move on, though, let's talk about blend shapes. That's the other thing that's supported. So for blend shapes are also defined in the scale animation, where it's just a bunch of tokens, A, B, C, D, and E, as well as their weights over time. And then for the mesh, you have a relationship to your blend shape targets, which are other meshes, and as well as relationships to the animation source. So it all should make a lot of sense if you guys want to write tools to essentially write your own skinned characters in Python and so on. This is all, I think, pretty sensible way to represent a character. This is what we developed essentially to get our characters out of Presto and into other bits of software. But to get other bits of software to support it, we really had to provide a full character so that the industry could know what to import and export. So if you go to the downloads and videos portion of openusd.org, you'll see there's this USDSkel example. I would say that this USDSkel example is my main contribution to USDSkel. This is a Toy Story 4 character, background character. I think her name was Camilla originally. And we were able to, I basically took her and made a, shining example of what we think USDSkel should look like that also exercises all of the tricky edge cases that might trip up other pieces of software and put it out there so that other DCCs could support it. So if you have questions about this character, whose name is humanfemale.usd, happy to answer questions because I'm responsible for this. And we're actually going to use this asset for the rest of the talk. One of the great things about humanfemale.usd is I don't need to get legal permission to talk about it because it's totally open source. So any bits of third-party software Pixar wants to evaluate, we don't need to use our own, IP to test it. We can use human female as a way to test other tools. The next part of this is we're going to take a little tour of basically how to get humanfemale.usd into other tools using USDSkel and sort of what's supported and what isn't supported. And then I'll do a live demo. But these next videos are kind of pre-canned, just to give you a really quick overview and tour of what's supported. So the first tool I'm going to show you is called USD View. This actually comes with the USD distribution. It's just a standalone way to view USD files, and it's really great for debugging and manipulating these files. What I'm going to do here is enable the guides, which show the skeleton for human female. So pretty standard stuff. Just playing back some keep alive motion. If we look closely at the face of the character, you'll see there's blend shape animation. And there's also this rig complexity variant, where we can switch it from high to face bones, which switches from blend shapes to basically what I call the face cactus. It's a bunch of bones that approximate the influence of the blend shapes. And yeah, not every tool supported that initially, or every tool supported variants. Then we have reduce, which takes away the face. So even though we're talking simple stuff, USD itself has a lot of interesting features like variations or on a file, including LOD. So we have a medium and low LOD, which is supported by every version of rig complexity. So we have LOD on both rig and geom. So we want to make sure every tool supports the concept of having these LEDs. So we added that to this character. So again, even though it's a simple concept, just skinning and blend shapes, there's a whole lot to test and exercise in a pipeline for just these simple things. So that's why this character is as elaborate as it is. So that's USD view. It's kind of the ground truth. So yeah, what I sort of covered is why this is important. Even though this seems simple, there's a ton of edge cases that are useful for developers to test their software with this character. Blend shapes, initially there wasn't a lot of support with this, actually, in a lot of DCCs. So we had to really work to get them to import it. Joints with unusual transforms. Pixar, we get symmetry in our rigs by having negative scales in X on half of our body. Turns out a lot of tools like Blender and Vicon did not support that until we provided this asset and had to work with them to say, hey, no, this is a very standard way of rigging that we need to be supported out there. So that was one thing we had to test. And the other thing was non-identity bind transforms. The idea that a mesh isn't just have identity 111,000 when you skin it. And some tools didn't support that. And so any tool that didn't support it, we'd see the shoe was off on this character. So there's a lot of great things that are tested by this simple example. All right, so with that, here's another fun thing. If you download this, you'll notice on Mac, you can actually open preview and see a USD file. USD support is actually built directly into Mac OS, iPad OS, and iOS. So that's pretty neat. It even works with Quick Look. So you essentially have a USD renderer that can show this, natively in Mac. And I'll get to later, you can actually even create what's called a USDZ file, and you can text these files to people and see them inside iMessage and stuff, which is kind of weird, but cool that we have this, OS level support on Mac for USD. Here's what the asset looks like imported into Maya. I am happy to report blend shapes are finally working. This was like 5+ years working with Autodesk to get USD blend shape import and export supported, but it's there now. So I'm thrilled that this is functional. Houdini supports this just fine using layer operators or LOPs. If you drop in a file node, you could point it at a USDSkel file. In this case, we're going to get that open source version. And there she is, human female, playing back in Houdini. Note that in LOPs, it's just rendering directly from USD to the viewport. But if you want to do mesh level manipulation, you can go inside of SOPs context and use a USD character import, point it to the LOP node, hit accept. And this is actually, I think, a Kinefx character, which is Houdini's character system. And then you could wire it up to a joint transform, joint deform, and actually see it deformed right there. So really impressed with the level of support that Houdini has. Unreal has pretty good support for USD. I believe it's just a plugin that you can just enable in USD, and then you can drag and drop USD files, including animated USD files, and there they are playing in your game. I think Epic Games has a lot of interest in more and more supporting virtual production with Unreal Engine. And since so many VFX houses are using USD, it's a natural fit. I think games, it's a little less common, but certainly for virtual productions in VFX, this is a very common way to get characters, I believe, into Unreal Engine. Unity also supports USDSkel. They were actually first before Unreal to support it, though I found, last I checked, which is maybe a year or two ago, it wasn't the most seamless experience. Hopefully it's been improved since then. But suffice to say, there is USDSkel support in Unity. And then finally, I just wanted to draw attention to NVIDIA Omniverse. That is NVIDIA's kind of like standalone hub that can interact with any DCC and show you essentially the USD equivalent of it. It's actually a really good tool just for inspecting what's in a USD file and manipulating it, because it sort of works natively with USD. Like USD is the native scene representation in Omniverse. It's not translated to anything else. So that's another really cool tool. All right, so with that, it's time to actually show some software demos. So we're gonna go ahead, I'm gonna show two demos. I'm gonna show you Maya, and I'm also gonna show you a markerless mocap system called Flow Studio. Both interop with USDSkel. So for Maya, this is just vanilla Maya. Let me make it full screen so you're not seeing my awful desktop. I'm just going to go to File, Import. I installed Maya 2025 recently on this Mac. There's no customization. And it seemed like Maya USD was loaded by default in the plugins. So that's great. I feel like USD is native enough now that you don't need to do anything fancy to import it. And I apologize for that slow import menu. There's a lot of network drives that have to be mounted and known before this opens up. That's a laptop configuration issue. Anyway, we're gonna open that human female keepalive.usd, and we are going to, if you look at the options, you'll see that there's like animation data is an option. You want that checked. If it's not checked, check it because you want that motion. But there's not that many things you need to twiddle or configure. You're more or less just do file import, and you're going to get your data. Translation isn't super quick. Not quite sure why that is, but it gets the job done. If it's going to be slow enough that it's, I can't even access my menu. Try hitting escape. Nope, we're stuck just watching the hourglass. I was hoping to go to a different folder, but it looks like full screen has eliminated that option, but it's getting there. I guess one thing I could do while that's imported is show you a quick preview of Wonder Dynamics, which is, if you go to app.wonderdynamics.com, is a markerless mocap system that works with USDSkel. I have here a video that I shot of myself. Download it. Sorry, let me go to the actual project. So this is an interesting tool where you upload a video and then you get essentially a USDSkel file of the motion, potentially on a 3D character. This is a video that I've already processed. It takes about 45 minutes to process a video, so I don't want to do it live. But if you go to export video and you go to the source video, we can essentially view. Looks like we're done importing. Nope, still beach bowling. Okay, let's go ahead and look at the video we just downloaded. So this is a video of myself dancing around. Want to see how mocap would work. Doing the Charleston from the side angle is a torture case for mocap systems. So I want to see how it works. We'll get back to the markerless case. It looks like the import is done right here. So here is a human female in Maya. I'm going to click 6 so we can see the textures. And note, we do Z up at Pixar. So that's why she looks like that. That is not a bug. That is a feature. That is how we work. And we expect other tools to support that. I did mention that you can get these characters running on your phone. So I'm going to give you a little demo about how to do that. Basically, how to create an AR version of this asset that can run on Mac OS. So if you import this into Maya and you want to, first thing you want to do is put a -90 transform in X so that it's now Y up. That's all you need to do. And we're going to export this as what's called a USDZ file. But before I do that, I just want to show you guys that, yes, this is indeed a skeleton you can manipulate. You can grab the leg and it's totally skinned and working. And it does have blend shapes and so on. But if you want to get this working on your phone, what you do is you actually go to File, Export All, and you can export USD. So you can round trip it. You can import into Maya, do some modifications, then re-export it as a USD. And yeah, I think you just make sure you got materials and everything. You're using, I'm going to hit use animation range so that we're not going outside of what we have animation for. Export all. And what we're going to do is, for the file format, rather than do USD, we're going to do USDZ, where Z stands for zip. What USDZ does is it sort of zips the mesh along with all its textures and everything so that it can be, used in a website or on a phone. We're going to go ahead and maybe put it in downloads or something so I can find it easily. And I'm going to call this TD forum test.usdz. And so that's going to go ahead and export. And one of the cool things about these, you can actually text these to people, believe it or not, and it works. I'm actually just going to use Slack to send it to my phone. And then I'm going to show you on my phone what it looks like. So we just did that. Let's go ahead and minimize Maya, or just not make it full screen. And then if we go to downloads, we should see that file. Do a quick look, make sure it works. Yep, there she is. Now I can go to Slack, and I'm going to just send Slack myself that message. Now it looks like it's 150 megabytes. That's a little disappointing because the original asset, it was just tens of megabytes, you know? So it's Maya is doing something, maybe exporting too many attributes, and it's getting a little bloated, but it's all good. And it's processing. Not sure what it's doing to process my file. It's a zipped USD file. And I'm going to bring up Slack on my phone. All right, so I'm going to send it to myself. And now I'm going to turn off screen share so that I can see you all and see what I'm showing you all on my phone. So I'm going to do something very low tech. I'm going to bring something up on my phone and then hold it in front of the webcam. So I'm going to search for messages for myself. Okay, these are Slacks I've sent myself. I'm going to click this file. It's going to download, and at some point you're going to see like view file show up there. I hope. Okay.
Live demo.
View file. No, I mean, you should. It's totally live. This is not canned. I am doing it live. So I'm going to hit view file. All right, and then you get this little AR/object mode, and then here we go. Here's the object. There is human female on my phone, including we can actually embed it in the scene in AR. Now this is going to be extra hard to demo, but in theory we can. That's not going to work the way facing my wall. But what's cool is you actually can embed it into the scene and get like a little character on your desk playing back and so on. But anyway, give it a try. There are USDZ examples online. You can download them and try doing AR mode and so on. So it's that's kind of a party trick, but it's funny because we can take our assets and put it on our phone and stuff. Like I've made that a crew gift to people on my team. I'll take animations they work on and send them a text message with it so they can see it. That said, that's not the real use case, but it's actually nice when I'm working with like Disney marketing, who they don't have like a full pipeline to use and view files. If I send them a USDZ file, they all can see what I'm talking about on their phones and so on. One more demo. I did want to mention Python a little bit. So I'm going to do a screen share again. We have this tool called USD View that I alluded to earlier, which comes with USD. And we're going to open up an asset, just anything. I'm just going to open up any asset right here. What's cool about USD View is it's both shows you the ground truth of what's in the scene, and it gives you a nice Python interpreter for being able to query or manipulate the scene or make overrides. So as a TD doing pipeline work, it's amazing. So we've opened up the scene. This is actually one of the exports from that markerless mocap system. It exports a camera. I'm going to choose a camera by going to View, Camera. So it's both doing camera capture as well as character capture. And here is this professor character that was applied to the mocap data of me doing the Charleston. It both gives you like the entire scene graph of what's in here. You know, like for instance, if you want to see what the skeleton looks like, you'll notice that there is an armature. This is the skeleton. You can go to the joints, and that's a list of every joint in the body. If you go to anim, these are the rotations and the scales over time. So let's say for some pipeline project, you just want to print out what all the joints are in their hierarchy. You can go ahead and go to Window Interpreter. Now you have a Python terminal. And one of the cool things is it pre-populates a bunch of variables with what you have selected in the viewer. So if I just want to, I have this joints property selected. If I just want to print it out and get a Python object, I just use the View API. dot property dot get. Those are all my joints. I can just assign that to a variable. Let's call it joints. Oops. Joints equals USD view API dot property dot get. And now I can do something like, for a joint in joints, 1, 2, 3, 4, print joint. And there's the list of joints. So you could write that to a file, send an email to someone with these are the joints in your scale. But basically, if you want to do USD Python development, I love using the interpreter in USD View to get that done.
Guys, do you have any questions to USDSkel or anything that Paul just mentioned?
Hi, nice to meet you. Thank you for the presentation. It was very insightful. And I've seen that the latest version of USD has got embedded OpenExec, kind of preview. And I wanted to know, what do you think OpenExec is going to, maybe with USDSkel, and also USDSkel, it's like kind of an execution. So why isn't it embedded in OpenExec? Why is it separated? So just kind of know of an overview.
Wow, great questions. That's like power user questions right there. So thank you for asking those. Yeah, so you're absolutely right in that there's a little bit of tension between OpenExec and USDSkel. But let me first explain what OpenExec is and wants to be before I answer the second question. So OpenExec, there's been a lot. So right now, USD isn't an execution system, which means it can show you a scene, but there can be no execution where one attribute drives another procedurally. Like for instance, there's no concept of a constraint without an execution. If you say one object is constrained to the other and you move that object in USD, the other one's not going to go along with it unless you have a concept of execution. So it's really just showing you what's there, but not allowing it to really be more of an engine for doing animation or things like that. So this has been a request for a while. And what we're actually doing, our internal exec team that is working on Presto is working on taking the best practices from Presto execution and getting into USD. I'm seeing the changes drop right now. It's hard work because execution is extremely complex to make performant. That's sort of the secret sauce of Presto. But we don't want to make USD overly complicated and specific to Pixar. So OpenExec is trying to make it agnostic to any sort of execution. And that could include things like advanced rigging. But to start, we're literally trying to do simple stuff like constraints, just the most basic things. So ultimately, we do expect more complicated rigs to come through OpenExec, but don't hold your breath. It's going to be a little bit. We're only just getting animation splines into USD right now. So in the meantime, the way USDSkel actually does something like execution, like skinning and blend shapes is execution, that's actually happening through what's called a Hydra computation. So Hydra is the system to go from the USD scene graph to what's drawn in the viewport. In that translation for what's in the scene description to what's in the viewport, you're allowed to change the data. It's almost like having a vertex shader that does skinning in a game engine. That's sort of like the way USDSkel works. There's actually compute kernels that do the blend skinning and the blend shapes, which allows it to run on both CPU and GPU, which is really cool. But it's super focused on just that one thing. It's not a general execution system. So it's slick, it's fast, it runs on CPU and GPU, but OpenExec will be a more open form, any kind of rigging, lattices will be supported, things like pose-space deformation, neural nets, it's all going to be part of it. It's going to be a while before that hits. We're still trying to make Hydra better. There's going to be a Hydra. Anyway, I'm going really off on a tangent here, but it's a deep question. And that's the sort of thing where if you, I would encourage you to also reach out in USD forums to people, because there's people that eat, live, and breathe OpenExec who probably could answer the question better than me. But it's an interesting topic to poke at.
Quick question from my side: what kind of level, Paul, would you need to use USDSkel in Python? what are we talking about? How much should you be like Python developer level? Which kind of level would you say is necessary to basically use it at least?
I mean, the basic thing I did, like, of just like reading attributes and printing them and doing things like just to use Python to understand what's in the scene. It's pretty basic. If you actually want to, like, let me tell you something you might want to use USDSkel for. There's often this tension of whether or not the transform on the character should be in the hip joint or on a top level group. This is always something, different pieces of software have different expectations. And let's say a certain tool needs it to be on the hip. Houdini really likes that, for instance. I've got to write a USDSkel script to do that. For that, you really need to understand like the underlying operations. Like, I need to take this matrix and combine it with this other matrix. So you got to multiply it, you know? You need to know what you want to do first. And then the API lets you do that quickly and write it out. I would say the actual Python is simple, but you need to know what you want to do and why. And that might be more advanced. So the kind of things I do with USDSkel is fairly advanced, but the actual Python API, I think, is fairly simple. But definitely read the docs, because you don't want to be in the business of just reading rotations raw and doing like math on them and writing them out. We actually have a skeleton query object that can give it to you either in local or world space or joint relative space. Because depending on what you want to do, you might want to do if you want to amp up some animation, you might want to take the joint relative transforms and multiply their rotations by something and then write it back. If you do that in world space, what you do to the arm is going to propagate crazy down to the wrist. So you sort of need, it's the API is, you want to use the right API and you want to know definitively what the goal you're doing is. But that said, I feel like I wouldn't want to do it any other way at this point, because then you need to learn every software's very specific way to work with the character. Whereas with USDSkel, once you know how to work with that, you can work with animation that belongs with any software effectively. So.
But I mean, that's the benefit of USD in general, like the portability. So basically, you would say the level that you need Python-wise is more on the same level. Like if you know how to use the Houdini API, like on the basic level, you probably will be okay with handling USDSkel on the Python level.
I think so. And actually, one pro tip that I learned recently. So the way I use USD is there's lots of good examples in the actual code base of how to use it. And we have a lot of code at the studio, but someone was asking me a very basic USD question the other day, which was like, hey, I want to print out all the points for this mesh. What's the quickest way to do that? And I was like stumbling on the API, and I was like, oh, let me just ask ChatGPT. And it actually worked amazingly well, because it's totally read all USD's docs and it printed out a 100% working Python snippet. I'm like, I can't do that with our proprietary software, Presto. It's never been absorbed by the LLM, but like, it's not a bad idea just to ask the question in natural language to get the little bit of API to do it. Now you need to know what to ask, and like that thing I told you about, like, how do you factor out, like, how do you take a parent transform and put it in the hip of a character? Might tell you that pretty effectively.
It's a little bit gambly, because like a lot of the experience I had I also used like GitHub Copilot. I made a course out of it. It can be, go in the absolutely wrong direction, and you circle forever trying to, and especially if you miss a certain level of education in certain things. So, for example, a lot of people will use like ChatGPT without knowing basic Python understanding, and then they end up in this like endless circle of prompts, basically. And I think that is the worst part of using AIs. It's always good to make it easier and faster, but I think it's bad to kind of like find just a quick and dirty way all the time. I think that will pay over time.
I should clarify. It's a way to read the docs with natural language. So if you think there's an easy answer, print out the points attribute, something you can verify quickly if it's doing the right thing. If it's easy, you can get the answer. If it's hard, it's going to make something up that won't work. So totally. You have to know what's easy and hard first. But what I meant was, like, if you're getting started, you want basic API tips for how to get at, the different attributes and do things. Seemed to work fine when I checked it.
Guys, if you're interested, like we offer Python courses for Maya, Houdini, Max, and Nuke, and also advanced courses for people who want to go more into teamwork and pipeline level.
There is USD support in Nuke. I forgot to mention that. We absolutely import USD files to Nuke and doing things like that. So
it's everywhere, basically. I mean, that's the idea of having it's on the lowest level, as you said. There is a few limitations that you cannot do because you are so attribute based, kind of at the end of the day. Okay, final question, guys. Does USDSkel supports Maya deformers and clusters directly, or we should convert these data into skin weights?
Skinning weights. I mean, my impression is that skinning weights are a cluster of sorts, but yeah, you got to bake it out. I'll give you one more tidbit about how Pixar gets stuff into USDSkel. So like I said, our rigs are not in any way simple skeletons. So we actually have a system called, we call it Frame Baker, that takes the mesh and moves every joint one at a time and figures out the closest skinning weights that reproduces the deformation of the ground truth. So we essentially have a rig baking process to get USDSkel out of Presto. I believe Houdini has a way to doing this. It's sort of like a capture mechanism. I think it's called skinning capture, where you give it like an example, calisthenic, and then it figures out the skinning. So you essentially have to do that to bake your rig out. So yeah, converting complex rigs requires a sort of baking. I saw one more question there.
Also, we should use single chain rigs. Is that a follow-up?
Oh, so it should all be a single hierarchy. Yeah, you don't want to have any breaks in the hierarchy, which I know is possible. Keep it as one continuous skeleton. No islands, floating out there in the skeleton.
Thank you very much, everyone, for joining and getting a little bit into the USD world. If you guys are interested, we have a newsletter and we do this TT meetups every month. Next month will be about virtual reality. How we can use VR for visualization and all the kind of industrial and also production visualization. So super interesting with Dan Frank. Tune in and subscribe to the newsletter. Paul, thank you very much. It was always a pleasure to have you. I'm looking forward to do something similar again in the future, whatever it is. You're always on the interesting side of like research stuff. I think that could be something we would do, probably something in the future. But I really like that you work on this kind of stuff, because I feel like this kind of elements, slowly connect software and make them more accessible, basically. And I think something like having something easily on your phone that you can see and look, I think can make things, even this simple thing can make a review process actually slightly easier and simpler. If you can like web browse your asset without always opening a big software or something like that. I welcome you to join us live and also watch the previous episodes, and I'll see you on our next TT meetup.